Alright, so let's bring it in, everybody. Okay. So, where are we at? So, agenda today, we're going to quickly go through scanf again. We're going to talk about conditional flow statements, or the if statements we talked about on Monday. We're going to review the logical operators, so that's greater than, less than, greater than, equal to, less than or equal to, or not equal to. We're going to talk about else if, and we're going to talk about compound logical operators. So just real quick, that's not where I want to go. No.
Alex.
I'd use that tone with me.
So about that group text though.
We'll see.
Email.
No, that takes too much time.
So, got ourselves a program here, got ourselves a variable. So just remember that with scanf, we specify our format string. We can specify whatever we want here. We can say int b float c. We can say whatever we want. And we can scan them in any order we want to. So I can say %f, %i, and then I can do an ampersand, where are we at here? An ampersand c, and then an ampersand b. We can scan them in any order that we want to. Doesn't really matter as long as your format identifier again corresponds to which variable you're using. So again, you have to have a %f for floating point. You have to have %i for an integer. So right now, the first number you type in will be stored in A. Second number you'll type in will be stored in C, and third number you'll type in will be stored in B. So that's scanf again. So talking about the if statements we did yesterday. So let's say we're reading in one integer. If, well, I'll just go through and I'll do every single if statement really quick. If A is, so equal is our equality operator. That means, so the left side is equal to the right side. So this is actually not equal. This one I didn't actually talk about on Monday, but I meant to. So A is not equal to 10. So it's the exact inverse of equals.
Exclamation point equals this.
Yep, exclamation point equals means not equals. A backslash? Yeah, that's kind of the this is kind of what you see in math. That's quite kind of equivalent to math, but it's easier to type, I guess.
Okay.
So just think of whenever you see an exclamation point, think not. We're going to expand on that a little bit later in the class. So not equals to 10. So we have, that's not a 10, that's a, so then we have A is greater than 10, A is less than 10, A is greater than or equal to 10, or A is less than or equal to 10. So I'm just going to go through and I'm actually going to expand on our if statements here. So let's say for our in-class assignment on Monday we had type a number and prompt the user to enter a number and tell them if it's right or not. So I'm just going to kind of expand on that and build a program that does that. Right. So our number's 10. So if the user guesses 10, then they're correct. So let's expand on that a little bit. And let's say we want to respond a couple different ways instead of just you're correct or you're wrong. So we can actually chain our if statements together by saying else if. So we can say else if, and then just like our first if statement, we're going to provide another condition to the inside the parentheses. We're going to say A is less than 10. And we're going to say guess higher. So we can continue to string these out. Yep.
If you put like A is less than or equal to 10 in one phrase, like one if statement.
I don't know what you're saying.
Like, could I put like if A is less than or equal to 10 and 2 if statements for that.
But we want the reason we have different if statements is because we want to provide different responses. We want to take different logical steps. We'll talk about that a little bit later. I think I hear what you're saying. So when we use, so then we'll have an else statement saying, just guess again. So when we start at the top, we check our first if statement. If that's true, the statements inside the if statement are executed. And then we jump then the program execution continues all the way down at the bottom, past the else statement. So if A is actually equal to 10, we'll say the program will print you are correct, and it'll continue on past the else statement. If A is less than 10, it'll say guess higher, and program execution will continue down here. So we can so program execution will continue past that. And now this is where we'll print under all the circumstances. But you are correct, we'll only print if A is equal to 10. Guess higher will only print if A is less than 10. And guess again will print under all other circumstances. So basically, else is the catch-all block. It'll catch all other circumstances that haven't already been caught by the if and the else if. So we can also chain more else's ifs together. We can say else if. We can go on for as many as we want to. We could say this as many times as we want to. We could say, let's guess lower.
So then when would it say guess again if you go lower?
Yeah, so right now it won't. But you can still provide it. But you as the programmer have already caught every single instance that's going to happen. So it's not, but you can still say it.
Okay. So let's just say actually writing.
Well, yeah, I can take this out and it does the exact same thing now. So yeah, again, if it's equal to A, it'll just execute what's inside that if statement and skip everything else, no matter what. Even let's say we have some conditions that are true. Let's say it's we're gonna change our criteria. So your guess of A is going to be greater than 10. All right. So when I say 11, it's going to say you are correct. But it's never going to say guess lower because we already had an if statement that was true. So if we have one if statement that's true, then we say else if, another one that's true, that one's not going to execute too. Does that kind of make sense? So it's going to say you are correct, but even though A is also greater than 10 down here, it's not going to say guess lower because we already had a true case that already executed. So when we have a group of if statements, as soon as one of them is true, it'll execute the statements inside the brackets and then continue on below the last else or else if. So a couple other things. We're not really limited to just one if statement. We could say if we do want to do something like that, if we want to output under all circumstances, all we have to do is take the else off and just say if. So we can have a bunch of if statements, and they'll all execute independently of each other. So it'll test whether A is greater than 10 here. It'll test whether it's less than 10 here and greater than 10 here, regardless of the context of the operation. Just keep in mind that in order to do else if and else, we have to have an if statement started off. So we could, let's say we want to build off this middle one here. We could say else. Just say nope. And so if A is less than 10, it'll print guess higher, and if it's not, it'll print nope. Were you stretching? Were you just stretching?
Yeah.
Okay.
I want to ask a question.
Oh, you wanted to ask a question?
No, I said why would I?
Oh.
Because
Once you get like 3 sentences in, I just kind of.
Wow, that's so rude.
Wow.
Thanks for being honest, though.
Nice.
I told you that.
He's
a
gonna
couple
ace
times.
this class, I tell you.
Oh, God. All right, so That's if statements. So
Will like the guess lower part not like print out that if it's got like something above it? Like so you have like
no.
guess lower.
So if it's so our if statements execute from top to bottom. We check our first one, our second one, our third one. That's only if we're stringing them with if, else if, else if, else if. If we're just saying if, it'll check every single time.
So check the first one, second one, third one, fourth one.
Not this one, because this one's an else. If A is greater than 10, then this is never going to execute.
Okay. It's not.
Yep.
But if it's lower than 10, we'll put higher. So we'll put Snoke or show.
But Snoke just doesn't show up right
No, it'll show up if you put in 11.
now. Oh, because that's everything else that you have.
Yeah, so just, again, keep in mind that the if statements are separated. So, yeah, those are, think of these as separate blocks, I guess. And again, whenever we say if, it's always going to check what's inside that case, what's inside the parentheses first.
Okay.
And then if there's any else ifs, it'll execute those if the previous condition wasn't true. But as soon as it hits a true condition, it's going to execute what's inside the brackets.
And it completely ignores the guess lower one because you have that.
No, it's not. It's going to if I put in 11, it's going to say you are correct, nope, and guess lower.
All three of them. Okay.
Yep.
So
Because if it's just a raw, if it's a plain if statement, it'll execute under all circumstances.
So, like, could you run this real fast? Just like you can see.
yeah.
You don't believe me?
No,
I
no,
just got confused.
Even I understand.
You are correct, nope, guess lower, and this is where we continue.
Okay.
So it's kind of difficult to understand. It doesn't help that I'm using different bracket styles for everything. One thing that's really good habit to get into that I still haven't developed is always putting your brackets either on a new line or right after your last statement. So you can see my brackets are all over the place. One thing that's really nice is to try and be consistent. So if you have an if statement here, then you have your first bracket and your closing bracket. Either do it, just be consistent. So either put it right after the, okay, so you can see my editor highlights it there. So that's our opening bracket, and then the blue is our closing bracket. So the opening bracket can either go right after the right parenthesis,
That makes sense.
or you can put it right there. Just try and be consistent. It's something that I don't do particularly well, but you should. Yep.
Is there a way to like limit their input to like 4 digits or something?
What do you mean 4 digits?
Like, I want them to guess a 4-digit pin so they can't enter 5 or 3 digits.
It's totally possible, but basically, there's no way to do it with scanf.
Oh.
Basically, what scanf does is interprets whatever you write into the terminal.
Yeah.
Oh.
What you could eventually do is there's a function called getChar, which gets 1 character, and then you could build a string out of those characters. You can only get 4 characters, and then you have to interpret that string as you have to try and translate that string into an integer and number. It's a lot of work, so by all means look into it. It's kind of interesting.
Oh, you like learn that?
No. All right, so where are we at? So, all right, yeah, I forgot about this. Remember, quiz 2 on Friday. Assignment 2 is due today at midnight.
It's assignment 3.
Yes, it's assignment 3. Just kidding.
I even get it too.
I know that because I turned it in last night because I've been working.
Okay.
I turned it in this morning.
Oh, did you know? Does it actually run? Are you sure?
Yeah, it runs.
Okay.
Carter helped me because I couldn't get it to compile.
All right, so this is quiz 2. So for quiz 2, remember that's on Friday. So you should, at this point, understand int float char, variable assignment. So a equals 10. Printf format specifiers, precision and padding. Remember that. So I don't have any markers here.
There's one right
How
here.
many links are you at right now?
So precision and padding all apply to floating point integers. So this is our default. I'll just type it on my computer, whatever.
Are we doing the quiz now?
We are doing the quiz on Friday.
Alex.
Yeah. Guys, stop. Guys, stop. Please.
I'm not doing anything.
All right, let's. So remember, this is %f is our default. Is our default floating point. Remember, we can say 0.2 or 0.3 or 0.4 for whatever number of decimals we want, and we can say we want it to be 10 total wide and then 2 decimals. So I'll ask maybe one question about that. Just keep that in mind. Scanf, reading in numbers, characters, floating point numbers. Basic, plus minus divides, divide, multiply. And compound, plus equals, minus equals, times equals, divide equals, arithmetic operators. If, else, logical operators, all the ones we talked about today. And basic ASCII logic. So just thinking about, if I have capital A and I add 1 to it, I'm going to get B. And if I have capital C and I subtract 2 from it, I'm going to get A. You don't need to know the numbers, but just keep, I'll have very simple questions like, if I add 5 to n, just remember that I take n and I go down 5 characters, or I go back 5 characters.
Wait, if you add, is it down and subtract it's up?
Yeah.
Okay.
So, like C, again, subtract 2, I get to A, add 2, get to E.
Okay, that makes sense. Sounds good.
So, keep that in mind.
You had class today?
What? Yes, we do. So, again, that's our basic if statement. That's our if statement with else. We can say else if too if we want to, and specify different conditions. So, the last thing we're going to talk about today is logical operators. So when we're writing our if statements, inside our condition part, we can specify multiple conditions that can either all have to be true, or one of them has to be true. So let's say we want to have multiple correct answers when a user guesses a number. So we can say A equals 10. So if we want to have multiple things that any of them can be true, we say or. We say two type straight thingies. It should be the shift key in your backslash key. So this will say you're correct if A equals 10 or if A equals 11. So we can accept multiple correct answers. And we can string these together as long as we want to. So you can say, essentially this will be read as A equals 10 or A equals 11 or A equals 99. And we can string those together as long as we want to. Now, if, now this isn't going to work for this example because none of these numbers are equal. So that says or. It says if any of those conditions that we specified are true, then it's going to execute the statements inside our brackets. But we also have and, which is 2 and ampersands. So this obviously can't be true, because what this is read as is A is equal to 10, and A is equal to 11, and A is equal to 99. And obviously those three equalities are never true.
What's something that worked too?
Let's see here. Let's say we have multiple numbers. We're reading in int B, int C. So we'll read in 3 integers. So we can say, let's say we want all of them to be equal to 10. They have to guess 3 numbers and they all have to guess 10. So we can say B equals 10, and we can say C equals 10. And so,
okay.
yeah, we could change any of those 10s so they could they have to enter 10, 11, 12. Or you could say, remember we can say or, we're saying and right now, so that's saying A equals 10 and B equals 11 and C equals 12. So in order to get the program to output you are correct, you as the user have to enter 10 space 11 space 12. But you could also have it so the user only has to guess one of them correctly. Yeah, so right now, a user would still have to guess correctly for one of them. They could say 1, 1, 12.
Be correct, but if you have and, I think
All of them have to be correct. Whereas with this, only one of the conditions has to be correct or be true. So I could say 10 space 0 space 0, and it'd say you are correct. I could say 0, 11, 0, and that could be correct. Or I could specify all of them to be true, and it would still work. All this is saying is that one of those conditions have to be true. And remember that we don't have to do this by any means. We don't have to have 3. We can have 2. We can have 5. We can have 100 of them. We can have our whole line. So if you have multiple conditions, you can just so we want to use if and else if we want to take different actions when a condition is true. But if we want to take the same actions when a condition is true, we want to use these compound operators. So when we want to say correct, and there's multiple conditions under which it can be true, we can just delimitate our conditions with, remember, 2 and ampersands for both of them being true, or however many of them being true, or this character. I refer to this character as a pipe. It looks kind of like a pipe, but it's shift backslash whatever. Well, what would you call this character?
A pipe.
Why does it have like 2? Like,
Two?
on the keyboard it shows like 2.
Yeah, it shows 2 split.
Does it?
Yeah.
Oh,
called a
Martin
scan.
doesn't.
Oh.
Yeah, because I don't know, because
You really could.
they're dumb.
Alright.
Alright, so that's about it. That's all I have for today. So our in-class assignment is going to be a little tricky. A little bit of text to it. So basically what we're going to do is prompt the user to enter 3 numbers. And if either of the first 2 numbers are greater than the third, inform the user. So we could say int A, B, C. And if A and B, if either of them are greater than C, then we say either of our numbers are greater than the third. And it's tricky, and I'll admit that it's going to be tricky, but now if both, so think of when I say either, think of or, and when I say both, think of and. So both the first numbers are equal to the third, inform the user. And if either of the first 2 numbers are less than the third, inform the user. So otherwise, inform the user that none of the conditions are true. Use logical operators, or, and submit to day 10 in class. Yep.
I guess it's just called a vertical bar.
It's a vertical bar. Okay.
Wait, so